Okay, and the second part, we're basically on the bottom of page 489 where it says equation conversion. So since we've been converting polar coordinates and rectangular coordinates back and forth in points, I've done that. We know how to do that. Now we're going to talk about equation. So if I had a polar equation that looked like this, how would I transfer or translate this into a rectangular equation? Let's go ahead and take a look at what this looks like first. So let's go ahead and take a look at our graphs or our calculators. You need to go to your mode and change to polar. You need to be in polar coordinates.
What should our window be?
Go ahead and graph this first. So go to graph and input this graph and see what you get. It's a circle. It's a circle. Adjust your windows to -5, 5 on the this direction and the direction, same thing, -5 and 5. Actually. And then your theta go from 0 to 2 pi. And you should get the circle. Oh, because your grids are squished. It's a little squiggly. What happened last time when you got the circle? What was the problem? On the little squiggly line.
It was the
T, right? So and you got theta from 0 to 2 pi. You just your what's your theta set to? 0 to 6.28.
Yeah.
You should get the circle. I don't know what's going on.
well,
Are you in degrees or radians?
I just think the calculators don't know how
For the
to do a
raise.
circle.
Oh, there's old.
Oh, hey.
It's an oval.
Okay, so it's a circle. So you are going to expect when I change this into rectangular coordinates, you would get a circle's equation. Okay, so let's see how we do this. Okay, so what do we know? We know that x is equal to r cosine theta. We know that y is equal to r sine theta. We know that x squared plus y squared is equal to r squared. We also know that tangent theta is equal to x over y. Y over x, you're correct. Y over x. So the problem is that I don't have any of these here. I have cosine theta, not r cosine. I have r, not r squared. So I'm going to arbitrarily make this work by multiplying both sides by r. So it's going to be 4r cosine theta. This is going to be r squared. Now we have some stuff to work with. R squared is that. So let's go ahead and put that in. And I have this guy. R cosine theta is x. So this is 4x. Aha. So now I am in Cartesian coordinates. I'm in x and y coordinates, right? Everything has been properly moved over. I just need to manipulate this. So I'm going to go ahead and move that guy over. Now I'm going to complete the square by adding a 4 on both sides. And that 4 allows me to now put this guy here as x minus 2 squared plus y squared is equal to 2 squared. So isn't that a circle? Right, with a center of 2 and 0, radius of 2. And that's exactly what you got in your polar coordinates. So all this came from this guy, right? Okay. So this is what we're talking about. This is what we're doing. This is what we're doing. We're doing equation conversions here, okay? So let's do example number 4. Or no, sorry, is it 5? Example number 5. Convert that okay, secant theta. So I'm going to go ahead and move that into 1 over cosine theta. So now I multiply this guy over here. I get r cosine theta is equal to 4. Ah, I know this guy. What is this guy? This is x. X is equal to 4. So what the graph would look like this. So let's go ahead and verify that. Put in your calculator. You're still in polar. So I can put r is equal to 4 secant theta. Or you're gonna have secant button.
No.
No, so it'd be r over cosine theta. And see if you get that line. Are we good? You got it? Everybody got it? Yeah. I'm gonna call that a success and move on. Example number 6. Now we're gonna go from rectangular to polar. X minus 3 squared plus y minus 2 squared, 13. Okay, so let's go ahead and do this out. I'm going to get x squared minus 6x plus 9 plus y squared minus 4y plus 4 is equal to 13. Okay, so we have this guy, which is what? If I add those two together, what are they? Isn't that r squared? R squared, right? Minus 6, this is r cosine theta. This guy here is minus 4 sine theta. And r sine theta. R sine theta. And 9 and 4 is 13, so they all go away. Right, 9 plus 4 is 13, they all go away. So this is equal to 0. So I pull the r out, I get r minus 6 cosine theta minus 4 sine theta is equal to 0. So r is equal to 0, or, so this guy could be equal to 0, or this guy could be equal to 0, which means r is equal to cosine 6 cosine theta plus 6 sine theta. What is r equals 0? R was the magnitude of the thing, right?
So it's the origin.
So it's basically the origin. This is just a single point, right? So this is going to be your true answer here. So graph that. You should get this guy here, right? You should get a circle with a, because it's the same thing, right? They're just transferred from Cartesian to, or rectangular to polar, right? I have a circle with a center at 3 and 2 with a radius of root 13. Okay, and that's what you should have done. Right? Okay, last but not least, let's do example number 7, and we'll do some fun stuff here with that. Number 7, using a radar tracking system. A radar detects 2 planes at the same altitude. Their polar coordinates are 8 miles and 110 degrees, 5 miles and 15 degrees. See figure 6.44. How far apart are the airplanes? So I have from here, I'm gonna go 100 degrees, 8. Is it 8? 8 and 110, I'm sorry. 8 and 110 degrees. And then over here, I have 5 and 15. 5 and 15 degrees. Question is, how far apart are these two? What is X? Right? So I know the length here. The length here is what? 8. The length here is 5. Angle between the two is going to be 110 minus 115, so it's going to be 95 degrees. So basically I have a what? I have a side angle side question. I want to find this guy. So side angle side, remember we used the law of cosines. Five degrees, right? 95 degrees. So X is going to be equal to square root of that. Right, that's it. And then you get 9.8. Okay. All right, we're done. You don't remember this?